Hey everybody. So I'm going to walk you through how we do these various return on investment um, problems or formulas using Excel, because we don't need to become experts in the math. We just need to understand how a return on investment works and how to kind of read it and understand it so that we can get some basic evaluation of how our investments work. So up on the screen, I've got just an example problem. It's very similar to the assignment problem for this chapter. Um, and you can see that we're comparing two investments. And the first investment requires a $10,000 cash payout up front and then returns $6,000 at the first year, 5,000 at the end of the second year, and 4,000 at the end of the third year. The second investment opportunity also requires a $10,000 upfront cash payment, and it returns 3,000 at the end of the first year, and then 6,000 at the end of the second year, and 7,000 at the end of the third year. And we see that there's a 12% hurdle rate, or that's the rate set by management as the basic rate that typically it's set based on the cost of capital. So like we think we'd be losing 12%, maybe our money's invested elsewhere where it's earning 12%. So for these problems, that's what we need is an understanding of the cash flow happening from an investment and some interest rate that's set by management that they often call the hurdle rate. So the way I set this up is over here on the left, you can see I've got the two companies and then our beginning cash payout and then our, so I'm just going to go ahead and enter this information in. So for the first product, the Porcupine Quill product, we're going to say up front, $10,000 in cash gets paid out. So we have a negative $10,000 cash flow on day one of this investment. And then it'll return $6,000 in positive cash flow at the end of the first year. It will return 5,000 at the end of the second year. It will return 4,000 at the end of the third year. The poop polisher, we also pay out $10,000, but it will return 3,000 at the end of the first year and 7,000, no, 3,000, 6,000, and 7,000. So we're all set up. We've got our information in our problem here. And so the first thing we want to figure out is what's the total return, which really just means what is the amount we're going to receive back from the investment minus the amount that we're going to put in. So really, since we already have the amount that we're paying out or putting into the investment as a negative, to find this, all we do is take the sum of all of the cash flows. So minus 10,000 plus 6,000 plus 5,000 plus 4,000. And we can see that we're going to make $5,000 more than what we put in. So in this case, we're putting in $10,000 and we're getting out 15,000. And then for this investment, do the same thing. And we'll see on this one, we're actually going to get a little better return. We're going to get $6,000 over and above what we put into it. So as far as if we're comparing the two, the second investment gets the win, so to speak, on total return. Okay, so the second one is payback, and this is super simple, except except that we're not. It's much easier when we're getting the same amount of payback each year. All payback means is how many years does it take us to make our money back? So we can see that if we pay out 10,000 up front and we get 6,000 back after 1 year, we haven't earned our money back. But at the end of the second year, we get another 5,000. Now we've earned our money back. Sometimes people will just do simple payout, meaning it won't be till 2 years that we earn our money back. And some people will do the payout where they, I guess, feel like it has more detail. So let me show you the more detailed way. That's how we'll do it for this problem. Is I'm going to say, okay, I paid out 10,000 and I got 6,000 back at the end of the first year, which means I'm still $4,000 in the hole, right? I paid out 10, got back 6. So of that $4,000, I'm going to get 5,000 back in year 2. So I'm going to get all of that 4,000 plus I'll be 1,000 ahead. So to come up with a concrete number of how long it takes it to pay us back, what I'm going to do is say there's 1 year in which we haven't received back everything we have, plus in the second year, then we'll make back what we're going to do. So I'm going to say this equals the 1 year, year 1, plus, and then I'm going to say if after year 1, I was still $4,000 in the hole, $4,000 divided by the total amount I'm going to make in year 1, which is 5,000, which I can actually just click on this here. And what this will do is give me a number. We don't want it as dollars though. We just want it as a decimal of 1.8. So even though we're going to get paid back in 2 years, we're actually going to get paid back 5,000 in the second year. So it took the whole first year plus 8/10 or 80% of the second year for us to get our money back. So that's how we do payback. So in the second year, we can see that after 1 year, we put out 10,000, we got 3,000 back. So we're still 7,000 in the hole. In the second year, we got 6,000 back. So we're still $1,000 in the hole. And in the third year, we're going to do 1,000 divided by 7,000. And that will tell us. So we have 2 years plus the amount that we're still in the hole. So 3,000 plus 6,000 is 9,000 from the 10. So 1,000 divided by the amount we're going to make in that third year. So we're going to say it takes 2.1. We'll go one more decimal so they match. 2.14 years to make our money back on that one. So we can see that if we're comparing them side by side, the Porcuquill product actually has a quicker payback than the poop polisher. And we can see that because it makes its money, more amounts of its money up front, whereas the polisher makes more of it near the end, which leads us to net present value. So net present value factors in the idea that the longer it takes us to make our money back, the less valuable it is. In other words, if I can give, if one of you wants, if I owe you all $1,000 and I give one of you $1,000 today, and at the end of the year I promise to give someone else $1,050, which is the better deal? Well, like in this problem, our hurdle rate's 12%. So if I gave you $1,000 today and you invested it and made 12%, you'd have $1,120 at the end of the year. Whereas the person who I just gave $1,050 to, they would have $1,050 at the end of the year. So the fact that you get your money earlier allows you to reinvest it at some interest rate that we're going to use the hurdle rate for. So getting your money earlier tends to give you a higher net present value. Okay. Again, this is a little bit of a complex thing, and we learn more about it in accounting courses, but even then we don't go super deep. But they're whole businesses who make their business on this truth, right? If you've ever heard of J.D. Wentworth, they purchase structured settlements. So if somebody has, they've won the lottery and they're getting paid so much per year for 20 years, but they decide they really need the money, J.D. Wentworth will go in and will pay them some flat amount today so they can have their money today, and then buy the structured settlement and collect it over time. So maybe someone is going to be getting, $100,000 a year for the next 20 years, which is $2 million. Well, J.D. Wentworth will go in, do the math, and offer them $1.6 million in cash today. They're happy because they get their $1.6 million in cash. And J.D. Wentworth's happy because they're going to collect $2 million spread out over the 20 years, and they're going to make a profit. So the present value or net present value factors in this idea that money today is worth more than money sometime in the future. And because it's hard for us to understand that, we use the present value, which means how much no matter if we get the money today or next year, how much is that worth in today's dollars? Okay, so let's just take a look at how we use Excel to do this. We have to be careful because there is a function in Excel that's called it's called NPV, so net present value. The problem is if we just use NPV and then highlight all of our data, we're going to have an error, because what it does is when we put in our rate, then our first numerical data it's going to assume is after a year of earning this interest rate. But our payout is today. So here's how we do this. We're just going to put this equals, and we're going to click our payout amount, or our beginning investment. And then we're going to say plus, and then NPV, the hurdle rate, ours is 12% on this problem, comma, and then we're going to hire all the cash, the positive cash flows in the future. So that's the formula. So when you go to do this, you can just kind of copy this formula and just make changes for anything that's different. But it's the beginning investment, shown as a negative, plus the NPV, or the net present value, of those future cash flows we're going to receive back. So the net present value of this whole investment is $2,190.23. What that means is it's $2,190.23 greater than if we had earned exactly 12%. I know that's confusing, but if we earned exactly 12%, our target or hurdle rate, then our net present value would be zero, but we're earning $2,190 more than that target rate. Okay. And so typically when we're evaluating for ROI, any positive net present value is considered a good investment, because it means we're making back more than our base hurdle rate. So for this one, I'll do equals the initial investment plus parenthesis NPV for net present value, open parenthesis 0.12 for our rate, comma, and then highlight my rates. And it looks like our poo polisher is actually going to make us a little bit more over and above that, even though it takes us a little bit longer to make our money. Because we're making back 6,000 instead of 5,000, our net present value is going to be a little bit higher. So what rate are we actually earning? That's what leads us to the IRR, or internal rate of return. This one's pretty easy. We can just say equals IRR. And for this one, we can just highlight all of the cash flows. All right, so our internal rate of return is 25.35%. The porcupine quill, and 23.96% for the polisher. So on our internal rate of return, it's a little bit less, which is interesting, right? Because it came out with a higher net present value. All right, finally, our profitability index. All the profitability index is our present value of our future cash flows divided by our initial investment. And so I'm just going to do this equals NPV for net present value do the rate, highlight these three, and then I have to divide it by the initial investment. What was confusing about this, where people make errors, is we want the initial investment as a positive. So I'm going to use a function in Excel that's called ABS for absolute value, and then click on that initial investment. So that will express it as 10,000 rather than negative 10,000. So my profitability index is 1.22, which means it's 22 times. So the, how do I put this? The present value of my future cash flows is 0.22 greater than my initial cost. Okay. We'll do the same thing here. Also, when we're using Excel, I don't have to keep doing this twice. I can just use my little function to my little fill tool to fill it. It will do the math for me, but I was doing it twice each time so that you could see the formula twice. So equals NPV, whoops, 0.12, comma, highlight those guys. Then we're going to divide that by the absolute value of the cash payout. And this will actually work better if I put all of this in parentheses here too. So there we go. So on this one, it looks like overall the polisher is our better investment. It's got a higher payback. I mean, it's got a higher total return, a higher net present value, and its profitability index is slightly higher. Although it does look like they're both good investments, right? Both of them are giving us a positive net present value. They're both giving us really nice returns. When our goal is to make 12%, they're making over 20, 24 or 25% each. So my recommendation would be, if you could only choose one, then invest in the polisher unless there are other non-financial reasons to invest in one or the other. But if we have the funds, we should invest in both of them because they're both good investments. Anyway, I hope this is helpful as you're doing the assignment, and I hope you have a terrific rest of your day, and we'll see you later. And as always, if you need help with something, don't be afraid to reach out and let me know.